Hello students, welcome to the second video of chapter probability. In this video, we are going to learn different operations on the probability. In the last video, we had learned about making sample spaces and how many kinds of events do we have. In this video, we will learn how to deal with the events and what are different kind of operations we can perform on it. So these are called algebra of events, right? The very first thing is complementary event, right? Otherwise, you have learned all these things in junior classes, but not in a very elaborated manner. Complementary event is what? Like in the last video, we had just learned how to write the sample space or the possible outcomes for a particular event. Let's say we have an experiment of tossing 3 coins. So this would be the sample space, right? Let A be defined as this. The event only one tail appears. You can see here only one tail, one tail. These 3 possible outcomes make up the sample space or the event which defines only one tail appears, right? So these are the possible outcomes we had taken out of these 8. This is a compound event, right? We had just learned. Now the complementary event. Complementary event is just the negation of this event. Negation means you have to take rest of the possible events which are in the sample space but not satisfying this event. Okay, let me simplify it. See, the event is only one tail appears. So what happens? Out of these 8 possible outcomes, we took 3 which are satisfying this particular condition, right? That means the sample space had 8 events, 8 simple events, right? And when we formed an event A, which is only one tail appears, 3 has been used here. 3 have been used here. That means 5 are left. 5 are left in the sample space which do not satisfy. You know? So that is called complement. If you remember in the sets also, if we had a universal set and we used to keep the things which belong to A inside this. Universal set is like, you can just compare this with universal set. Universal set is your whole sample space, right? And this A event is like this. These 3 have been placed inside this. Rest of the 5 will be here. So this is the portion which is the complement of A. So in that case, in sets we used to write A complement is U minus A. Universal set minus A. Here we have S minus A. The whole sample space minus the events, possible outcomes which are defined for this particular event. That means A complement is the set of the elements which do not belong to A. They are there in sample space, but they do not belong to A. This is called complementary event. Next we have the event A or B. A or B. If you try to relate this thing with sets, you will learn it very easily. What are events A and B? A or B. A or B means when we have to choose either A or B. So if you remember, like you have in a set A or B, the whole this portion is A or B. That means a particular event which belongs either to A or to B, right? That is A union B. A or B means that something which is there in the common portion, still you can keep it in A or in B, it will be written once, whether you take it in A or B. So actually it is A union B, nothing else. So event A or B. When the sets A and B are 2 events associated with sample space, then A union B is the event, either A or B or both. That means even if we have something here, it is included in this whole shaded region. So that is A union B. It contains A or B is A union B. It is a set which contains elements belonging to A or to B. And this is the shaded portion, right? Next one is the event A and B. Event A and B. Here, just try to connect this in the same manner with the sets. If we have two sets, A and B, the intersection of two sets A intersection B is a set of those elements which are both common to A and B, right? So that means this region is A intersection B, and A intersection B is exactly same as A and B. So when we are talking about possible outcomes which satisfy condition A as well as condition B, right? Those possible outcomes will be written here, right? Will be written here, and those will contain the events which are common to both A and B. That is A intersection B. That means events which belong to A and events which belong to B. And so it is exactly the intersection of the two events. So if you have two events, right, and you just take, if you want, I can take one example, like S is 1, 2, we throw a die. Let's say if I define event A as odd numbers, then what are the possible outcomes? 1, 3, 5. And event B as prime numbers. So how many prime numbers do we have? 2, 3, 5. Now what is A and B? A and B is what? A and B are the numbers or the possible outcomes which are common to both. That means a number which is odd as well as prime, right? A and B. That means a number which is odd and prime. So if we talk about those numbers which are odd and prime, then we have 3 and 5 which are common. So I have just used the concept of set, but only the topic is like you have to take about events, not this. When it comes to the probability, then you can find the probability of this event A and B. In that case, you have to consider this as the favorable outcome, right? Favorable outcome. So how many possible outcomes are there? 2 out of the whole sample space, which is 6. So we have 2 by 6 or 1 by 3 probability of numbers which are odd as well as prime. So which satisfy both the conditions, right? Next is the event A but not B. Event A but not B. So let us recall the set again. This is A and this is B. A and B. A but not B means you have to take events which are in the portion which is only A. That means if something is common between A and B, you have to leave that part. A minus B. Subtract that portion which is being shared by B. So only take those events which are exclusive to A. That means only A. This portion is called A minus B. If there is something common between A and B, you have to exclude that. So A minus B is nothing but A intersection with B complement, right? So this whole, see, this is B. Outside B is all B complement. And this is a portion which is common with A. So A intersection B complement, right? This is even A but not B. Next we have, this is very important topic and you will be dealing with these in detail in class 12. So the definition and the actual application you must know by heart. Mutually exclusive events, right? Let's say we have an event of throwing a die. S. Sample space becomes 1, 2, 3, 4, 5, 6. Now the events we define here, A, an odd number appears. What are the possible outcomes? 1, 3, 5. B, an even number appears. 2, 4, 6. Do we have anything common in these two? 1, 3, 5. Odd, 2, 4, 6, even. So there is nothing common. Clearly, the event A excludes the event B and vice versa. Excludes means there is nothing common. So when there is no outcome which ensures the occurrence of events A and B simultaneously, or in a very simple language, when we have like A is this, B is this, and A intersection B is 5. That means they are two disjoint sets. Okay, it's written like two disjoint sets. If you talk about sets, you can make A and B like this, right? So when there are two sets, when there is no intersection at all, those are called mutually exclusive events. Like in this case, we have numbers from 1 to 6, half of them are even, half of them are odd, and these form two events. That means they have no intersection. So they are disjoint or mutually exclusive events. Occurrence of one event does not impact the occurrence of the other one if they are independent, right? So next one is mutually exhaustive events. This is also very interesting. Let us take the same sample space when we throw a die. This is 1, 2, 3, 4, 5, 6. Now number A, a number less than 4. Okay, see, a number less than 4. 1, 2, 3. B is number greater than 2 but less than 5. Greater than 2 is 3, 4 but less than 5, so it's not included. C is a number greater than 4. Greater than 4 is 5 and 6. Right. Now, if you take an event like A union B union C, right? So what is this? If we take A union B union C, it will be 1, 2, 3, 4, 5, 6. Here we had three events. The sum of those possible outcomes, the event space, this is the whole set itself, the whole sample space itself, right? The union of all the possible events in this case gives us the whole sample space, right? Then they are called mutually exhaustive. Like if we go by the previous example also, let us A is odd numbers, 1, 3, 5. B is 2, 4, 6. Again, if we take A or B, A union B. So what will we write? 1, 2, 3, 4, 5, 6. Again, we got the whole sample space. So these are two mutually exclusive events as well as mutually exhaustive events. Because the sum of these two events, we are getting the whole sample space. Right? So here, let us do one example. Consider the experiment of rolling a die. Let event A be getting a prime number. Prime number is 2, 3, 5. B is getting an odd number. Odd number is 1, 3, 5. Now we have to use these operations what we have learned. A or B. A or B is nothing. See, A or B is nothing but A union B. Numbers which are occurring once in both the sets, or even if they are repeating, you have to write it once. So here we have 2, 3, 5, 1, 3, 5. Union gives you 1, 2, 3, 5. Like 3 and 5 are repeating, but they are written once. 1 and 2 are occurring once, but they are written once. So this is union only. A and B. That means A and B both. The number says prime and odd. Okay, we have got the same example. Prime and odd. Again, we have these two sets, 3 and 5 are common, which are in both the sets. The common elements. So this is the sample space. A but not B. A but not B. Right? Events like in A, what is common between A and B? It is 3 and 5. So events like A minus B. A minus B. So we have only like 1 because 3 and 5 are common. So take only that portion. Like here, if I write 3 and 5 will be written here, 1 and 2. Now 1, 3, 5 is there. This is A. So A, but not B. So take out only that portion which is exclusive to A. That is 1 only. Right? Not A. A is 2, 3, 5. Sorry. A is 2, 3, 5 and this is 1, 3, 5. So it is 2. Right. This is 2. The next is not A. So here, even if B is there, we only have to consider A. A is this circle, right? A is this circle. We have 2, 3, 5. So what is left outside this? If we talk about the whole sample space, 1, 2, 3, 4, 5, 6. Leave 2, 3, 5 here. So element which is not in A are 1, 4, and 6. They might be here or outside this, but they are outside A only. So 1, 4, 6, which are in sample space but not in A. Right? So this was all that we have learned in this chapter of probability. If you have any doubt or you want to take up classes, do contact me through Urban. Thank you for watching the video.